This conference will now be recorded.
Yes, good morning everyone. So today's discussion is ICC2 flow, or it's also a fusion compiler flow. ICC2 and fusion compiler both are same, but only difference is fusion compiler will also integrate synthesis, power reduction algorithms, STA, physical verification in one bundle, right, in one license. That is called as fusion compiler. ICC2 only we do PNR, placement and route. Right? So in this course, what we cover, right? What is today's agenda of discussion? So why this course? Next is what is covered in this course. Next, the third thing is 3 weeks plan. Next, the fourth thing is your doubts. Do you have any doubts? Right? I will discuss on your doubts. So this is what the today's agenda. What is we do? So why this course? Right? See, this course is helpful. Right? This course is helpful if you. This is helpful if you know Innova's flow, but you're not aware about fusion compiler flow, right? Then you will easily get the what is fusion compiler flow, how to what is IGC2 flow, right? So by attending this course, see, you should be having already physical design idea. What is physical design, right? By attending this course, you can easily handle fusion compiler or IGC2, right? You will become very flexible, right? You will become very flexible and you can easily handle fusion compiler or ICC2 by taking up this course. So I will teach in such a way that how to, if you want to get any information, how to do that, how to debug it, how to get the commands without user guide. Right? So that is how it is helpful. Third thing is, right, everything is explained in tool. Right? It's not like only in a notepad it is explained. So the course is done with help of tool. So here we use ICC2. Using ICC2, we will show all the commands, how it works, how to use the command for each flow. Right? Next is for each flow in physical design, how to use PD commands, how to use commands. It's like I'm not teaching what is the commands. That is easy. This command is for placement, but how to get the commands, right? That is what I'm going to teach. So how to use commands. This is what we going to. This is why this course is very helpful, right? So what is covered in this course? What we cover. So this is a big discussion, right? If I classify ICC2, right, ICC2 can be classified into the flow commands. I can classify like this flow commands. Flow commands means like for import design, how do you import the design? So in the universe, you will be having read LEF, read Verilog, right, like that. So, but here we are going to import the design, right? Import design. We do by using NDM, new data model. So here we create a library. This I'll discuss in depth by using tool from next class. Here we create library. So what is a command to create library, right? Create underscore lib is a command to create lib. What is a command to create block? Right? Create underscore block is used to create the block. What is a command to create core area and die area? Initialize floor plan is the command to create the core area and die area. So what are this? These are called as flow commands. What is a command for port placement? You have many commands like set individual pin constraints. So you have create pin guide. Right? So these are the commands for pin placement. Right? Similarly, what is the command for macro placement? Even you have the command for macro placement command, and doing macro placement by file line analysis, that also I will cover. Like this is called as flow commands, right? This is flow commands. Normal commands. What is the command for course placement? What is the command for legalized placement? What is the command for placement optimization? So all these are called as flow commands. So first we will discuss on flow commands. Right. So all the flow commands starting from import design till routing and sign off. Right. We'll cover that. So starting from import design to routing. All the flow commands will cover. First thing. Okay. Second thing. Right. These flow commands are very easy. Right? Second thing what we cover here is in this course is we will cover if I want to get like height of a cell, how to get the height of a cell. I have a cells in the design, how to get height of a cell. So in the design, right, we have something called as objects. What are called as objects? Objects means anything which is seen in the GUI, right? That is called as objects. Objects are called as like cells, ports, pins, site rows, core area, block area, or die area, layers, metal layers, nets. All these are called as objects, right? Each object has their own properties, right? For example, what is property is called as attribute. Attribute. So, for example, object cell has its own different attributes. Like cell is having different attributes, like it is having height, what is width, what is area, and whether this cell is combinational cell, is underscore combinational, is underscore sequential, is underscore hard macro. So all these are properties of a cell. Right? Similarly, we have properties of a layer. Right? If we have any layer, what is a property? Metal layer. What are the properties we have? We have minimum. What is the minimum spacing? Right? Routing direction. So we have minimum spacing. What is routing direction? What is pitch? What is minimum width? All these are properties of a layer. Right? So for each class or for each object, what is the attributes available? And by using this attribute, how to get any information? For example, get the height of a cell, right? Right. Get height of a cell u1. I have cell u1. How to get the height? So how to get the height? So we have a command called as get underscore attribute, get underscore cell u1. What I want height. So get the slack. For example, I have one cell in the design, right? I have one cell in the design, like the cell u2, right? Through this cell u2, right? I have a cell u2. I have one flip-flop here. In between, I have one cell in the design. This cell name is u2. Through this u2 cell, what is the timing path available and what is the slack of this? Get that. I want through u2, through this cell u2. So how to get that? So to get that right, you should use the get underscore attribute command. Get underscore attribute, get underscore timing path, true minus true, what cell u2, what you want slack. So I'm getting the slack value through the cell u2. So you want to get site row height. So how to get site row height? So to get any values right from the design. So we should understand what is objects, what are different objects we have, how to get different attributes we have. See this attribute name, right? For cell, what is the attribute available? Height is available. So height I have used. For timing path, timing path comes under the category of objects. Right? Timing paths will come under the category of objects. Timing path. For timing path, if you look, what are the things available for timing path? For timing path, what are all the attributes available? So for timing path, we have what? One is slack, one is arrival time, one is required time. Like this, how to get different information from the tool for any objects, right? How to get different information. So this timing path is a object that I used for this timing path through U2. Get what? What is a slack? Get it. So like this, right? How to get different information from the tool for any object. So the same thing you have called as a get db commands, right? In Innovus, you have a get db commands. Instead of get db, we have get attribute commands. How to use get attribute commands for different objects. Object and class are both are same. And how to get their properties. What are the properties are available for each object, and how to use these properties to get the information from the tool. Like, we will discuss different types of commands like this, right? So by taking different examples. So one more type of command is there, right? Called as, see, one is get attribute. It is like get a db. In Innovus you have get db. Similarly, here we have get attribute. In Innovus you have set db. So here you have set underscore attribute. Few attributes I can set it. Right? Set underscore attribute. For example, I have a cell called as u1, and this u1 cell I have to fix it. Right? This cell I have to fix. How to fix this? I can use the command set underscore attribute. Next, what is the U1 belongs to which object? It is a cell. It belongs to object called a cell. Use the command get underscore cell. U1. I have to fix this cell, right? For fixing this cell, what I should do? So fixing means it has a this U1 is having a property called as physical status. So for any object, what are all the properties available? What are the different properties available? So we will discuss that how to get that, right? But this cell is having a property called as physical status. So obtain physical status. So this physical status, what we have to make? We have to make it as fixed, right? I have to make physical status fixed. For this cell, it is having a property called as physical status. I will make it as fixed. Means that cell is fixed, right? So fix a cell U1. So for example, I have one cell called as like U3 cell. I have some cell called as U3 cell. Set don't touch on that, right? Set don't touch on U3 cell. This cell U3 should not be touched. So then I use the command called as set underscore attribute get underscore cell U3, right? There is an attribute called as don't touch only. For every cell, there is an attribute called as don't touch. So you can use here don't touch. Don't touch. True. So set this attribute true for this cell means this cell will not be touched during the placement optimization. The cell will not be moved or it will not be touched means it will not my tool will not do VT swapping or not do upsizing. Right. So first we'll understand what is objects, what are the different attributes available, how to use these attributes to get the information and to set the attributes of a cell. Right. And next, right, we also see filter commands. Filter commands. I have all the nets in the design. I have all the nets in the design, but only I want to have signal nets. I don't want to have power nets, or I want to have only clock nets in the design. How to get that? Or I want to have only sequential cells in the design. So first is right, get the sequential cells in design. How to get only sequential cells in design? So there is a command called as get underscore flat cell. So this command will give you all the cells in design, right? This command is going to give you all the cells in design. That is get underscore flat cell. But I don't want all the cells, right? I want only sequential cells. Then I should use the command minus filter. One second, just minus filter. So there is an attribute called as in this, right? You have attribute called as is underscore sequential. So how to get this attribute list? I'll tell you. Right? We'll discuss on depth for this, right? So there's an attribute called as is underscore sequential. So this is underscore sequential use here equals true. So this command is giving you only the sequential cells in the design. See, get underscore layer is going to give you all the layers in the design, right? This layer. So I have layer here. Get underscore layer is going to give you all the layers in the design. But I want only metal layers. So what I should do? So I should use the command, right? Like this. Get all routing layers in design. Get underscore layers will give you all the layers, like yeah, metal layers. It will give polysilicon. It will give diffusion layers, implant layers. All the layers it's going to give. N implant, P implant, P diffusion, N diffusion, polysilicon, contact cuts. All the layers it's going to give you. I don't want all the layers. I want only routing layers. What are routing layers? M1, M2, M3, M4, M5, M6, M7, M8, M9, like this, right? And so on. These are called as routing layers. I want to filter only the routing layers. Then I'll use the command get underscore flat cells minus filter is underscore routing layer. There is a command, right? Is underscore routing layer. There is attribute available. So not flat cells. I'm very sorry. Get underscore layers it is, right? The object is get underscore layers minus filter is underscore routing layer equals true. Means get underscore layer is going to give you all the layers. You filter only to get what? Routing layers. So that type of commands we are going to see the filter commands. We will see. I will just tell you how to use the commands. Later, you can only start writing the program. Right? It's not like only I am going to explain the particular command. No, I'm going to explain how to form these commands. To form these commands, what you want to know what are the objects available for every object in the design, right? These are called as object. For every object in the design, you have a command called as get underscore object name, like get underscore cells, get underscore ports, get underscore pins, get underscore site rows, get underscore core area. For every object you have. So how we are filtering it? By using the attribute name and attribute value. Whether is underscore sequential attribute name is there or not. So how did I understood is there is attribute name is underscore sequential. So for that, right, there is a command called as list underscore attribute. List underscore attributes. What are the attributes available? Minus application. Even give the application attributes minus class. Right? Cell means show all the attributes available for class cell. What are the attributes available? So now my tool will list all these attributes. A cell has height, a cell has width, a cell has area, a cell has is underscore combinational. So it is going to give all the list in the alphabetical order. By using this attribute only, I have formed these commands. So each underscore sequential is an attribute available for class cell. If you want to get the attributes for class layers, right, then use minus class layers. So we are going to see how to form these commands, right? So filter commands. After filter commands, we will understand few commands like used for fixing the violations. Fixing violations, you should know few commands. Fixing violation commands. For example, you have a net in the design. This net is N1 net. This N1 net is having a max capacitance or max trans violation. So what you should do is you should find the driver of this net. What is the driver cell name? And first, for see, only you are knowing what is a net. You have to find what is the driver cell name. And this driver cell you have to upsize or you have to do VT swapping. You should manually do that. So how to do it? So you want to do push or pull operation, right? Well, that is called as useful skew method. Like you should do push operation or pull operation in ICC2 by inserting buffer in the clock path. How to do that? So those commands, for example, I have a net N1. I wanted to find what is its driver cell name. How to find that? Right? I will use the command called as all underscore connected. This all underscore connected command, all underscore connected minus leaf, right? Net name. Net name is N1. Right? All underscore connected minus leaf. Net name is N1. N1 is a net name. So this command, if I use, right, my tool is going to give me the pins connected to this net. What are the pins connected? So right side I have two load cells, you assume, right? I have two load cells. So here the pin is A1, input pin. This side the pin is A2. So here driver cell is Y, right? So this command all underscore connected is going to give you the pin names. So this cell name is you understand that this cell name is U1, this is U2. Just I'll give some name U2 and this is U3. So this command is going to give you all the pin names. So pin names mean what? It is going to give you the driver pin name U1 slash. So 1 second, it is very difficult to write. It is going out. So I'll use easy note. So I have one cell here. This is U1 cell, and its pin is Y. It's connecting to a net called as N1, and this is connecting to load cells, right? This is A1 pin, right? This is A2 pin. Now this all underscore connected command is going to give you all the pin names. So what are the pin names here? The pin names are nothing but U1, right? U1 slash A1, sorry, U1 slash Y, because U1 is a driver cell name Y. So U2 slash A1, right? U3 slash A2. So it's going to give you all the pin names like this. Just give me 1 second. Right. So this is U2 and this is U3 cell and this is U1 cell. So now all underscore connected minus leaf N1 means this net is N1, right? If I use this command, I will get all the pin names U1 slash Y, U1 slash U2 slash A1, U3 slash A3. But I don't want this. I want only the driver cell name. First, what I do is I will take this command. I will give this to one more command. Means capture this result. Right? What is this command is giving? It's going to give you all the pin names. Capture this result. If I want to capture the result, use a square bracket. Capture the result. Give to one more command. I will use one more command called as get underscore pins. Get underscore pins, which is given by this command. So this command is going to give you all the three pins. Here minus filter, right? Minus filter the pins. What I'll do, I'll filter by using direction. Direction, this is attribute name, right? This is attribute name. Direction equals out. It's out of all these pins, which pin is having direction out? Only this pin is having direction out. All these two pins are having direction in. So I cannot use this. Then this command is going to result only this. Right? This it is what it is going to result. So I'm going to get a driver cell pin name. Even I don't want driver cell pin name. I want driver cell name. So driver cell is present here only. But still, how to get through a command? Again, capture this result, and in front of this, use the command, right? Get underscore cell minus of objects. Get the cell of object. This command is going to return this pin name, right? The meaning of this command is get underscore cell of this pin. What is the cell name of this pin? Right? Cell name of this pin is U1. So this command is going to return only U1. This command is going to give what? Get driver of a cell having net, driver of a net, right? U1. So for example, right, you similarly we were going to discuss all these commands. Why, what is the, how to use these commands, right? For example, I have like I have a cell here. I want to find what is the clock getting cell connecting to this. The clock pin is there, right? What is the clock getting cell name connected to this? This is ICG cell, clock getting cell. So how to find this? Right. So first we will see the flow commands. What are the flow commands used for a different flow? Next we will see how to get different values from the command. Means how to get the different values for different objects. Next we will see filter commands. Next we will see what are the commands used for fixing the violations. Get the driver of a cell, get the ICG connected to any clock pin, right? Do push and pull operation like fix violations, fix setup violation by useful skew method, right? Upsize the cell, right? What is the command? Right? Like apply keep out margin, like it is a halo, right? In we call it as apply halo. Apply keep out margin to cells with pin count more than with pin count more than 5, like this, right? We use different commands. So how to do shielding, right? Shielding, shield the clock nets, like insert antenna diode at particular area, get all shorted nets, get all nets which are shorted, So like that, right? Use different commands to get all this information. How to get the information by using this filter commands and attributes commands. So all these commands are used to what? Fix the violations, right? So apply keyport margin to the cells pin count more than 5. We are going to spread the cells if I apply keyport margin. Then I can reduce the cell density at particular area. So if you're having any IR drop issues, you can spread the cells. So like that, right? You can use different fixing commands to fix the violations. So next we will discuss on different app options. What are app options? Can you tell me what are different what do you mean by app options? So application options are the options which is going to govern the main command. Are options which is governing main commands. For example, right? You just you have example like report timing is giving you the timing violations. Like timing report is going to give. It's going to calculate AT, it's going to calculate RT, it's going to calculate the slack. That is what the report timing will do. So while doing report timing, whether you want to consider the crosstalk or not is considered or not. But you can control by using app options. One of the example, this is first example for what are app options. So if I want to consider, see by default during report timing, my tool will not enable the crosstalk analysis. But if I want to enable crosstalk analysis, then I have to use the command set app option minus name, right? A time dot. See the option, the command is not exactly same, but I can get it in the tool. Tool, I will tell you how to get the different app options. Now what I'm typing, it may not be exactly same because I'm not remembering it. Right? I can use time dot enable dot SI analysis minus value true. Means during report timing or during timing analysis enable the crosstalk. Time dot enable means during timing analysis enable the SI means signal integrity. For timing signal integrity is crosstalk. For DRC signal integrity is antenna violation. Right? For power and IR drop the signal integrity is electron migration. So please enable this crosstalk. So you want to do like second thing, right? During report timing, enable CRPR. Right? So what is CRPR? Clock reconvergence pessimism removal. So by default is not enabled means you can enable it, right? What you can use the same app option you can use and you can enable the app options. Time dot enable, right? Dot CRPR. And so during timing analysis, enable the CRPR. See, this command is not exactly same. So that I'll tell you how to get from the tool. Minus value true means during timing analysis, right? Enable the CRPR. Clock reconvergence pessimism removal. So third thing, right? When you're doing clock tree optimization, right? Your clock op is the command which is going to do clock tree optimization, during which you should enable CCD flow, right? enable CCD flow during clock optimization. During clock tree optimization. By default, it is enabled. If you don't want to use, you can disable it. Right? Few app options by default is enabled. You can check that. CCD means concurrent clock and data path optimization. During while building the clock tree, my tool is going to touch a set data path as well as clock path to fix the setup and hold. So fourth thing is during clock opt, give more importance for hold. Even you can set the app option. Right? During clock opt, give more importance to hold fixing. Right? Like this, I can set different app options. So what is this app option? What we are setting? All right. If I set this right app option, like I have app option like set app option minus name, right? Clock dot opt minus hold fixing effort high minus value high. See, normally my tool will do the both setup and hold fixing, but what I'm telling during clock opt, right? Give more importance for hold fixing. I'm setting through app option. This app option is going to control your clock opt. Now my clock opt will give more importance to hold fixing instead of setup fixing, because setup fixing we are already taken care during the placement stage. So these are called as app options. So we are going to see different app options used in the design for each and every stage, right? Not only different app options for each stage, what all the app options can be used from from floor plan to routing. Understand different app options, different app options during right? From floor plan to routing, understand different app options. What are different app options can be used? So this by enabling or disabling app options, your result may vary. So next is at the last small TCL programs. I cannot do bigger TCL programs, small TCL programs to get few results from tool. And user requirement, like user requirement. So if you want to get any information from tool, right, you can tell me, I will do that. Right? User requirement. So all these things we are going to discuss in this course, right? Especially with respect to ICC2. So first is flow commands, normal flow commands like create placement will do placement, legalize placement will do the legalized placement, clock opt will do the optimization, clock tree optimization, route opt will do routing optimization, route auto will do the routing. So the normal flow commands. See, we are not going to discuss in this order, but I'm telling you what we are discussing. That may be like during floor plan only I can discuss all these things. And during placement only I can discuss how to fix if you have any max cap and max trans violation, how to get the driver name, right? All those things I can discuss. So next is we are going to discuss about how to get any information from the tool for any objects, right? how to set the attributes, right? We'll discuss those commands. So next discuss filter commands. Get only sequential cells, get only the routing layers, get only the, so now I used one more command right here. Get only the pins which is having routing direction out. So use the filter commands. Next, write the commands for fixing violations. Manually, if you want to fix violations, right, write the commands, how to write the commands for that. Next, we will each and every flow, during discussing each and every flow, we will discuss a different app options. What are the app options governing? See, for example, what are the app options governing the placement optimization? What are the app options governing? So set the local cell density, set the fan out limit, enable the advanced legalizer. So we'll discuss different app options. Next, we'll discuss small TCL programs and few user-oriented questions. Like you want to get something from the design or something from the tool. So how to write the commands. That we will discuss at the last. So this is out. This is what we cover in this entire course. What is covered in this course. Next is right. Next I told what is the next thing is what is a plan. So this course is done for 3 weeks, right? What is a 3 weeks plan? So this is first week. We consider this first week. So first week is demo, like what we covered. That is today we are going to do demo. And tomorrow, right, floor plan commands along with we'll discuss what is attributes, what is this one, right? Class objects, class objects, attributes, and attribute values. So second week, what we discuss in second week. See, second week again I have 2 days, like Saturday and Sunday. So during Saturday I'll discuss what are the commands for like placement and CTS. What are the different commands used during placement and CTS, which covers all the things, which covers flow commands and what are the fixing commands, what are the different app options, everything will cover here, placement and CTS. Third week, what are the app options for routing and timing analysis. And see, this I can do in only one class, right? I can do only in Saturday. In Sunday, we will discuss on small TCL programs, how to write small TCL programs, automated programs. But you should be knowing TCL, basics of TCL. You should be knowing, right? I'm not going to discuss basics of TCL. If you know basics of TCL, like what is for each loop, what is how to read the file, right? If you know that, we will discuss that and user related questions. Right? This we are going to do in the this is a 3 weeks plan. What we have, right? And everything is done on tool, right? ICC2 tool is used, not like working in Notepad. Right? ICC2 tool is used to do all these things, these operations. It's tool oriented course. So now you can ask me if you have any doubts in this.
Hello, sir. Am I audible?
Yes, you're audible. Please tell me.
Yes, sir. Sir, I wanted to ask one thing. Sir, if somebody is doesn't know the Innova's flow, so is this course good for him?
Okay, so what flow you know then? Like if universe is not known, then what is the flow you know?
Sir,
At least you should be knowing
actually,
what is physical design, right? Doing
yeah,
complete
yeah,
physical
base,
design in 6 classes is not possible, right?
yeah,
But you
yeah.
should, if you know the operations, then you can follow this.
Okay, sir.
Just tell me, you wanted to tell something, right?
Yeah, yeah. So basically, like I have like basic knowledge of physical design, that is like STA and logic synthesis, but like I think so.
Hmm.
In Cadence, like it's the Innovus is the Cadence tool, right?
Yes.
Yes, sir.
Hmm.
So I have never like used that tool, so I have no knowledge of it.
No, no, it is not like you should be knowing universe, but
Okay, sir.
many will be knowing universe. They not be knowing compiler, custom compiler, like sorry, Fusion compiler, ICC2. So for
Yeah,
them
yeah.
specifically, this course is related. But similarly, many will know Fusion compiler. They not be knowing Innova. So last week we had done that course also. That is cadence flow. How to use different commands to do PNR in cadence flow. The same thing
Okay, sir.
we are doing for but Fusion compiler ICC2. So it is not that you should be knowing Innovas, but at least you should be knowing the basic flow. What is done after what stage.
Okay, sir. Like floor planning, power planning, like this.
Yes, you should be knowing the basic flow.
Okay. Basically
So
the
then,
theory part of it.
yes, theory. And if you have the working experience, that will be good. You can understand in better way. But if you know, that is good. Right?
Okay,
If
sir.
you're
And
not
sir,
knowing,
will
also you can
the
attend. So this course is not like okay.
yeah, yeah, sir. I wanted to ask one more thing, sir. Like, will this course cover like everything which you have told in 3 weeks?
Yes, all these are command oriented, right? Yes, it will cover.
Okay, sir.
It is say 3 weeks means every day it is for 3 hours. Like if not every day, Saturday and Sunday. Saturday 3 hours, Sunday 3 hours. The course is right.
Okay.
Saturday and Sunday it
Okay,
is
sir.
for 3 hours. So the flow will cover, I think.
Okay, sir.
See, only the one thing I can see, I can feel that if you are attending, right, you may not follow few things, advanced things. If you know what is, if I ask what is shielding, you know what is shielding.
No, sir. Actually, sir, I'm
That's what
learning
advanced.
VLSI, so yeah.
So, see, advanced things you cannot follow. At that time, you should be like more interactive with the mentor after the class,
Okay, sir.
or you can come to the institute once in a while and you can discuss. That it's up to your interest then again.
Okay, sir.
Let's see, if I ask macro placement guidelines, so whether you know macro placement guidelines.
No, sir. Actually, sir, like I have just like recently like started in this field, so I'm still learning. So this particular part of placement and routing, like I don't have much knowledge of.
Yes, that is what. So this flow, this course is helpful when you know one part of tool and other part of your tool you don't know. Then it is helpful.
Okay, sir.
Sir,
Yes. Any
excuse
other
me, sir.
doubts? Yeah. Yes, please tell me.
Yeah, sir. Do we also use a prime time tool, sir?
See, prime time. If you want, I can show you. There is nothing wrong in that. but as part of syllabus we are not including prime time. But what you want to understand in prime time, if you ask me something, right, I can show you even that also. Prime time license we have. So specifically if you discuss, right, I can cover at the last for half an hour I can cover.
Okay. Sir, is this
What you
like
wanted?
hands-on, sir? Do we get license to use this access to use this tool?
No, no, you will not get the license. The tool is not given with the whatever you're registering, right? The tool is not given, but I will be showing in the tool. The mentor will be, a trainer will be showing in the tool, but for you tool will not be given. So if you want to get the tool, you please contact the admin. Right? What is the cost you have to pay? This additional cost you have. Means see whatever we are
Okay, sir.
doing it, right, that is done on the tool. It is not done on the like notepad. See last time we did cadence. Cadence is done on the notepad. Nothing there. We didn't use any tool because we don't have cadence license. But this future ICC2 flow we are doing, I am doing on the tool.
Okay, sir.
Yes, any other thing you want to know in this? Yes, any other doubts? Whether anyone is already working in Universe and they want to know ICC2 here? Anyone is there like that? Okay, then right. These are the things we cover in the session, right? If the class starts from tomorrow, right? If you register, the class is going to start from tomorrow.